Hello viewers, Alan here. Welcome to my workshop. So I've done an assortment of projects over the years in my workshop. One thing I've never done is build an engine, and I think it's about time I did. So I cast about on the internet and found that the Webster engine sounded like a pretty good place to start. It's a single cylinder and specifically designed to be easy to make. So I thought, why not start there? So I had a look through the plans, and they're quite extensive. Worked out a bill of material, which you can't see properly there, and found that I had a lot of the stuff that I would need already lying around in oddments and misfits. So I've got a weight here, which will be the flywheel, or alternately I'll use this and cut a flywheel from that. But anyway, I've got a piece of 12mm aluminium which I'll use as a base plate. It's not as wide as it should be, but I've rejigged the dimensions and it should be sufficient. Now this isn't going to be a detailed how-to from start to finish. What this is going to be is I'll take odd bits of video as I progress, bits that I found challenging or interesting, or stuff-ups probably along the way, and let's get into it. So I thought I'd start by doing the base plate. Now I think you'll be able to see this has been in the scrap box for a few years and it's been kicked from pillar to post, so there's a lot of scratches in it. So it was slightly longer than I needed, so with the piece that I cut off, I had a quick practice at doing some finishing. So that was 2 passes with my cutter, my home brewed cutter, and that's alright, I guess. You certainly can't feel that line across there. This side I did with a single pass of the fly cutter. And I was very shallow cut, so you can still see there's marks and things in there. But because it does it all in one go, I think that's the process I'll go with, just to clean some of the surface up a little bit. So I wanted to do just a clean up on the surface. I didn't want to reduce the thickness of the material any more than it was necessary. So I did a couple of trial cuts, and it seemed that 0.04mm gave me a finish which I was happy with. So this is the first time I've had reason to fasten something in the vise with the jaws reversed like this, but of course I want this edge to be square to that, so I'll use the dial gauge to check that. So it's wandered off a little bit there, so I have to improve on that. Okay, I think I made a bit of progress here. I've stiffened this arrangement up a little bit, tightened the knobs and the rest of it. Noticed that this was a bit off centre in the vise, necessarily so. So I put a spacer in the back here so that when I do the vise up, the jaws don't tend to cock. And all those things I think have made a difference. I think a blind man would be happy to see that. So I'm calling that good enough. So I finished machining the ends of the base plate and drilling the holes off camera, and moved on to preparing the stock for the side plate and the crankshaft support plate. Oh, I reckon that's a pretty impressive cut. That's right on the line all the way down. Oh, you've got to get lucky sometimes. I must have the saw set up correctly, I guess. Anyway, on with the rest of it. It did start to wander off a little bit at the bottom, but at least it went to the correct side of the line, so I'm not upset about that. I think it's pretty good. Okay, so this is going to be the side frame. I roughed it out on the bandsaw and cut this piece out. That'll be useful for something, I dare say. Anyway, and I've got it sitting on the milling table, located against a pair of dowels, 16mm dowels, which are a good fit in the what do you call it, the the T-slot. So with this set up, I can now face the ends to bring this to length, and then change the clamping around without losing the position, and face this edge. So that's what we're going to do next. Oh, and I've got a 10mm end mill mounted, so it makes it easy. If I do get a good finish across here, then all I've got to do to get the correct length is what I want plus 10. Alright, we'll have a clean up and see what we've got. Okay, now I don't know whether you'll be able to read that, but we did in fact hit the mark spot on, and got it exactly on 143. So happy about that. Actually, is an interesting sidebar. I was really impressed to see how accurate these guys are. They're saying, I don't know whether you can read that, we're right on 143 dead there. I think that's pretty impressive that these things can be so accurate. Oh, and by the by, the clothes peg is on the end of the end mill because I was getting too many scratches and nicks from being a bit careless around the end of it. I thought the clothes peg might help save me from myself a bit. Okay, so I've rejigged the clamps, and so now I can take a clean up across this face. I'll just take a 1mm cut, and then all the action will be on the other side as I bring it to the correct dimension at this end and at that end. So I had just enough clearance here. Anyway, let's clean this up and see what it looks like. Well, I'm not terribly thrilled with that surface finish or the burr on the top here, so I think I'll do a 0.2mm climb cut back the other direction, see if that cleans things up a little bit. So that's definitely a bit better. Still got a burr on the top, I'll obviously clean that off. So it's done 3 sides, so I've got to turn it around so I can do the dimensions on the other long side. So I'm getting set up to drill the hole for the crankshaft here, and obviously it's highly desirable that the hole be concentric on the side plate and the crankshaft support plate. So that's what this setup's all about. And I've got a, what do you call that thing? Adjustable parallel, just to support it. So what I'm going to do is drill 12.5 and then ream to 12.7. Off we go. So that's my 12.5mm hole. So I'll get it set up with a 1/2 inch reamer. So I might have to finish that by hand because I think I ran out of depth down here. So just checking that with a 1/2 inch dowel pin. Yeah, that's beautiful. So while I've still got these 2 pieces aligned, I've turned them around in the vise so I can drill the holes in the bottom of the 2 pieces, which will and I have to thread those holes because they will take the screws that secure these pieces to the base plate. Okay, well that's an encouraging bit of progress. So I've drilled and tapped the bottoms of the side plate and the crankshaft support plate, and they're held in place with their screws now. And encouragingly, the 1/2 inch reamed hole lines up pretty well. There's this stainless steel bar, it's right on size at 12.7 1/2 inch. So happy with that. So I'm going to press on. Next bit will be to cut this diagonal off and mimic over there. They don't have to be exactly the same, it's an appearance thing. I mean, you could actually just leave it like that, but of course that looks crap. So anyway, the point is just to cut the corners off and get them looking roughly the same. So that's the next step. So this is the setup I've used for cutting those corners off. So I did the first one just using the scribed line, and then I've used that to set the second one. So I ran the dial gauge across that to get that level, and I'll just put the ruler there so you can see it. The target for this dimension there was 32, so I hit that pretty much spot on, but the down here was supposed to be 36, and I finished up with it at 37. It makes no difference at all to the function of the thing. It just means that I have my angle slightly wrong here, but like I say, it's only an appearance feature. It's not, doesn't have any function. So I'll chop this off now and then face that edge there. Right, so I'll be taking 2mm deep passes until I get down to there. And that, I think we'll call that. That's pretty good actually. So now I've got to flip it over and do this long edge. Okay, so I'm happy with progress so far. I've got both of these plates now to their correct size and profile. And I've put in these extra features, holes and tapped holes and whatever. And so now I won't have to do any more to these plates until I come back and put a brass bush or bronze bush in here as a bearing. So move on now to make the piece that goes up the back here, which is the cylinder head, cylinder body and cylinder head support piece, and that'll finish out the structural side of things. Okay, so I'm getting set to lop 11mm off the top of this block. I did think about using the bandsaw, but I didn't want to run the risk of it running into my line and causing me grief, so decided it's a good chance to use this cutter. I haven't used it before, bought it at a flea market years ago. It's a 28mm two-bladed cutter, and I've got it set for a depth of cut of 3mm. We'll see how that goes. Now if it behaves itself, I might even try it for 5. Anyway, off we go, we'll see what happens. Well, it seems to be eating that, so we could sneak it up to 5. Let's go with 4. I don't want to overshoot what it's capable of doing, of course. The cutter absolutely aced that. Left a beautiful finish too. So that was at 4mm depth of cut. I don't know if there's any point pushing it to 5, so I'll do another 4 since that worked out so well. So down 0.49 and hopefully we'll hit our mark. Right, shooting for 38. 38.01. Oh, I'll take that, that's pretty good, isn't it? 38.01. And the drawing calls for the spark plug to be an M10 thread with a 1mm pitch. According to the drawing, it should be using an 8.84 diameter drill, or that's actually a letter S drill, and that's what I've got mounted here. But my charts suggest a 9mm drill, which is obviously slightly larger. But I'll go with the letter S, and if I don't like the resistance to the tap as I turn it in, I'll open it out to 9mm. But anyway, I've got 2 concentric drilling operations here. The first is the letter S drill all the way through, and the second follow-up is to put a recessed hole here, a recessed bore I suppose, for the cylinders to sit in. And the ID of that bore, which should be 1/2 inch deep, is 25.4. But from my perspective, that's a little bit nominal. It just needs to be a close fit on the outside diameter of the cylinder where they connect. The worksheet suggests doing the cylinder first and then making this fit. But I don't want to do it the other way around. I think I'll make the bore here roughly 25.4. because it's easier from my perspective to bring the cylinder to size, because you can sand the outside of something rather than trying to open up a bore. Anyway, let's bang this through and get started. Alright, well, that's all the way through. Now I'm not going to try tapping it yet, because obviously I'd then have to tap the full length of the hole. So I'll switch over now to doing this counterbore. Weapon of choice for doing this counterbore is a 25mm slot drill. You might notice that the 3 cutting lips are different lengths, so this actually is able to be plunged into straight into the face work, but having the start hole there won't do it any harm. Well, the quill DRO is claiming that's 0.3, sorry, 3 thou under 0.5, so let's see whether it was right. According to this, we've got 5 thou more to go. Let's see whether that does it. It's got to be bringing me pretty darn close. Yeah, I reckon we can call that half an inch. So next step, or final step for this counterbore, is opening this ID out from 25 to 25.4. Okay, so I just ran the boring bar down there. Sorry, I didn't have the camera turned on. Anyway, and I'm reading 25.37, looking for 25.4. So I think I'll just do a spring pass at the same setting and see what that gives me. Alright, let's do a check measure. It certainly did see some material come out. Let's hope it didn't get overly enthusiastic. Yeah, what do we get? Well, I guess that's close enough to 25.4. So since I'm still in the right place, I might as well put the M10-1 thread in the back of this thing for the spark plug and find out whether this S letter drill hole is alright or not. It's feeling alright so far. I think now we've started, I might switch over to a better tap handle. That's a bit easier. I think I'll have that out there before I hurt myself on it. Alright, one spark plug hole. Right, so I think you can see that worked out alright. That's a 1-inch end mill. That's a pretty nice fit in there. So the boring operation worked out quite well. Okay, so pressing on, I've already done the holes for securing this block to the side plate. So now I've got 3 holes to do here. 2 get tapped for M3 screws, and the centre one is basically the intake port, I think. Anyway, the valve block gets screwed on there. Right, so those are done at 2.5 for the tapping. The one in the middle I've got to open out to 4.76. What will that be? 3/16. And the last hole in this piece of Swiss cheese is for an M5 screw that comes up through the base plate from underneath. This has to be tapped M5. Do a light dab with the countersink in this hole. This cut is really sharp, and in aluminium you don't really want to do it under power, because it'll run away. That's all it needs. Somewhat ironically, given that I'm working on quite small pieces for this engine, the project's given me the opportunity to use some of my cutters that I've rounded up in various places that I've never used before. So this guy's an 1.5" diameter slot drill, and I'm using it to plane a 32mm wide stripe across the back here. And we're going in at 2mm deep. So we'll see how much it likes that. I didn't seem to have too much trouble with that, did it? So now I'm going to take a final cut of 3mm deep to get to the 6mm depth that I'm looking for. Well, I think that's a pretty impressive piece of metal mowing. I reckon it's a pretty spectacular bit of metal removal. Yeah, this thing goes that way up. Now, people who've made this engine before probably wondering why I've left such a big lump here. Well, I read that these engines tend to run hot, so I started out with 25mm thick material, and I thought I might as well leave the material on this side and cut cooling fins into what will be the cylinder head. So that's why that's there. When I said earlier that I'd finished drilling holes in this bit of Swiss cheese, I was forgetting about the 4 holes for the cylinder head bolts. It's dopey. Anyway, so I have to drill a 4-bolt pattern on here. I'm going to use these socket head M3s, and I need a 6mm diameter clearance hole for the head. And because I've got this additional 6mm of material here, which will become cooling fins, I've got to relieve these holes down an extra 6mm, so 3.3 for the head of the screw plus 6, 9.3. So I've done one, and just get on and do the other 3. So that's got these 4 holes prepped ready for the 3mm through hole. But while I've got this set up on here, I'll pull this cutter out and put my spot facer in 5/8 diameter to take the spark plug hole down to the to this face level. Now, I haven't got one of the spark plugs in hand, so I'm not sure exactly what size is needed, but on the drawings it notes that there should be a spot face for the spark plug at 5/8 of an inch. So I'm going to use that dimension as the clearance. So I've just got to go the 6mm down here to get down to the original face, the specified face. Okay, I suppose looking at this, there's not going to be an awful lot of material left for cooling fins, is there? Yeah, well, we'll see how it goes. Right, well, I'm going to have a crack at cutting these slots to create the cooling fins here. This slitting saw is 2mm thick, so I'll just do several passes of that, and it should hopefully work out fairly even. I don't have much experience using this, well, I've never used this saw, so I don't actually know how much it's going to try to pull this out of the vise. So I want the slots to be 6mm deep, but I think I'll start off in the first instance going with 3mm and see how that looks. Well, that pass at 3mm deep seemed to work just fine, but now I've got a dilemma. Do I try 6mm, or, you know, I'm sure the cutter's up for it, but I don't know that my clamping is. That's what bothers me. I've had an issue before on a previous machine where the larger diameter cutter picked the work up and just ripped it out of the vise. So I think we'll have a second pass with a further 3mm. I'm going to do this at 5.9 actually, just to be a bit shallower than 6. So let's do that. It's a bit nerve-wracking, I've got to tell you. Alright, let's have a proper look at that. A bit of a clean up and a good look. Well, seems to have done a fairly clean job of it. So I think I'll press on. Only one cut left to get now, which is just as well, because I think this saw is starting to get a bit blunt. It's complaining a bit, but hopefully we'll get through this last cut. Right, well, I finished those cooling fins on the cylinder head. I don't know how much difference they'll actually make to the temperature of the engine running, but it gives it a purposeful look and it can't do any harm. Now, you might have noticed, or the astute or the observant amongst you might have noticed some extra holes in the base plate. That's because of my first major stuff up with the project. I started off trying to make it using materials to hand. The drawings call for 8mm material for the side plates. I used 10mm material and didn't allow correctly or sufficiently for the offsetting. So I just turned the plate around and drilled a new set of holes, which are the correct spacing. And I was probably going to replace this with, if the engine turns out alright, replace this with a correctly purchased and correctly sized bit of plate. But anyway, for the moment you can see the project through like that. Now, I guess with those elements done, the framework of the engine's complete, and I'm going to call a halt here, and in the next episode I'm going to get into the cylinder, the piston, the conrod and the crankshaft probably. So I hope you found this interesting, or enjoyed it anyway, and hopefully you'll join me on the next one. Cheers.